Hello students, and welcome back to another geometry video. Please pause the video and try this problem in your notes. It is from the last video we did. Now unpause the video and do it with me. So, we are told to identify the segment bisector of segment RS. So this is the segment RS that we're looking at. Identify the segment bisector. Remember that a segment bisector can be anything. A point, a line, a segment, a plane, a ray, any geometric figure. So, a segment bisector cuts something in half. So what in this picture is cutting RS in half? Well, it is most definitely this line right here. It is line N. And remember, there are typically many ways that we can name lines. I don't have 2 points on this line. You cannot say NM. You cannot do this, because N is not a point. Points use capital letters like R, S, and M. This N is lowercase. So that is the name of the line. So we can say line N. But we can't name it any other way, because we only have 1 point. So this is the only name I can give to this line over here. Okay, so we have identified the segment bisector of RS. Now, we want to find RS. And remember, when you don't have the line above it, it means that you want to find the length. The length of segment RS. So, I know that RS is this length right here. It is 4x plus 3 and 6x minus 12 put together. But that doesn't help me because I don't know what x is. So I need to be able to find what x is. Now, there's got to be some way to figure out what x is from this picture. Do you remember what these tick marks mean? Hopefully you do, because these tick marks are going to be here for the rest of the year, so make sure you know what these tick marks mean. What they mean is that this segment, RM, and this segment, MS, are the same. And if two things are the same, it means that they are equal. So what I can do is I can say 4x plus 3 is equal to 6x minus 12. Because line N is bisecting RS, it cuts it in half, which means the distance from M to R has to be the same as from M to S. Okay, so, So now all we need to do is solve this equation for x, and then we can figure out what the length of RS is. So, in order to solve this equation, I want my x's on one side and my numbers on the other. Does not matter which side, so I'm going to put my x's onto the left-hand side by subtracting x from both sides, 6x from both sides. I get negative 2 plus 3 equals negative 12. Subtract 3 from both sides. Oh, running out of space. I get negative 2x equals negative 12. And, goodness, we ran out of space. Alright, negative 2x equals 12, negative 12. So we're just going to move this up here. To solve this equation, I need to do the opposite of multiplying by negative 2, which is dividing by negative 2. And now, negative 12 divided by negative 2 is 6. Am I done? Have I finished this problem? No. No, I have not. Because what was the question asking me to do? It asked me to find the length of RS. What have I found? I have found x, which is not the length of RS. So what I need to do is I need to plug x in for one of these. So if I do 4 times 6 plus 3, 4 times 6 is 24, plus 3 is 27. So now am I done? Is RS 27? No. Remember, 4x plus 3 is just the length of Rm over here. And remember that Rm is half of Rs, because we know that this is a segment bisector. So, I know that half of Rs is 27, the other half is also 27, so all of Rs in total is 27 plus 27, or 27 times 2, which is 54. So the length of Rs is 54 units. That problem seemed very simple, but it had a lot inside of it that maybe we might not have seen upon first glance. So, hopefully that you got it right, and if you didn't, make sure you rewatch it so that all of it makes sense. But now, we're going to move on to what we have for today, which is the second half of section 1.3. So, we learned all about midpoints in the last video. Now we're going to learn about the midpoint formula and the distance formula. So, you should remember what a midpoint is, and you're going to learn, and you're going to remember what distance is, because we talked about both of those things in the last video. And you're going to be able to use the midpoint formula and the distance formula to solve problems. So let's jump right into it. What is the midpoint formula? Well, the midpoint, so remember when we talked about midpoint, when I think mid, I think middle. And when you talk about finding the middle of two numbers, say 5 and 13, if I want to find the middle of these two numbers, you might remember I can just take the average of them. And to take the average of them, I add them together and I divide by 2. And then I can find the middle of these two numbers. So 5 plus 13 is 18, divided by 2 is 9. And if you count 5, 6, 7, 8, 9, and you count 9, 10, 11, 12, 13, 9 is 4 away from both 5 and 13. So we have indeed found the middle. Now to find the midpoint, the coordinates of the midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. So all you have to do to find a midpoint is average the x's and average the y's. That's it. That's it. So yes, if A has coordinates x1, y1, and remember that these are going to be some numbers, we just don't know what the numbers are, and B is x2, y2, remember that those little numbers underneath, we're just saying that this is point number 1, and this is point number 2. That's why they have the little y with a little 2 next to it, so don't get scared by those. Okay, so if we have A is this point, B is this point, I take the average of the x's and the average of the y's. And of course, this is a nice picture that illustrates all of that. So, now that you know more about it, let's do an example. So, we are told that the endpoints of Rs are given here. Find the coordinates of the midpoint M. Do we need to graph this? No, we don't have to graph it if we don't want to, but pictures help me. And it is scientifically been studied that there is about 7 different parts of your brain that are active when you're doing math, and one of them is the visual component of your brain, the spatial reasoning. So pictures help you whether you think they do or not. So let's draw a picture. R is at 1, -3, and S is at 4, 2. So here is S, here is R. Let's try that again. Connect the dots. Beautiful. And now we are told to find the coordinates of the midpoint. Well, just by drawing the picture, it looks like the midpoint is somewhere around here. But I don't know what that is. What is that, like 2.5, -1/2? I don't know. I don't know. We can't tell just by the picture, so we need to also use our formula. So, the midpoint is x1 plus x2 over 2. This is just averaging our x coordinates and averaging our y coordinates. y1 plus y2 divided by 2. So, for each of our points here, we have x, y, and remember, we just call like this point number 1 and this point number 2. So that's where I get x1, y1, x2, y2. And now I just have to plug these numbers into my formula. I know, plugging numbers into formulas is not what math is all about, and it can be boring. But we are going to need this midpoint formula, and we're going to need the distance formula as we go on. So I will probably give my students this formula on a test. Your teacher might not. It depends. So maybe you should memorize this. But again, it's not that hard to memorize because I have the average of my x's, the average of my y's. So that's not too bad. It's not memorization if you think of it that way. It's more you truly understand what a midpoint is. Okay, so x1 is 1 plus x2 is 4 divided by 2. And then y1 is negative 3 plus y2 is 2 divided by 2. And this is, we say m for our midpoint, so these are the coordinates of m. That's why I'm writing it m parentheses. Okay, 1 plus 4 is 5 over 2, and negative 3 plus 2 is negative 1 over 2. Okay, and now you can keep it like this, but I prefer decimals when I'm graphing. So 5 divided by 2 is 2.5, and negative 1/2 is negative 0.5. Hey! That's what we thought it was in the yellow over here. So drawing a picture did help us. Because when we drew a picture, we got an idea of what the coordinates of this should have been. If I got something in the end that was like 3, 13, I would have been like, wait a minute, this 313 would be way up here. There's no way that that's the midpoint of this segment. So it's very good that we drew a picture. It helps us check our answer. Does this answer even make sense? Yes. Yes, it does. Okay. Alrighty. Let's move on to example 3. Wait a minute. Oh, that was part A. We got part B now. Okay. Part B. The midpoint of JK is 2, 1. Ah, so now we've been given the midpoint. Now they gave us the midpoint. Okay. So 2, 1 is the midpoint M. All right. And one endpoint is J1, 4. And now this M is in the way. That was bad placement. Okay. So this is JM, but we're looking for JK. So, okay, so this goes like further. Okay, I have no idea if that is the actual point, but it looks like it could be. Something like this. In fact, let me draw that in yellow. Because I think, so we know that there needs to be a K somewhere over here. Because M is the midpoint. We're told the midpoint of JK is this. So if that's going to be the middle, that means that our whole segment needs to look something like this. Okay, so where should K be? K should be somewhere around 1, 2, 3, negative 2. Oops. 3, negative 2. So I'm going to put that there with a big question mark, and we can use that to check our answer. But now, So, let's get a different color altogether. We know that M, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2, we know that this is equal to 2, 1. Because it's the midpoint, right? This is our midpoint formula, and this is what they told us the midpoint was. So we know that this is a true statement. Okay. Now we have one endpoint. One of the endpoints is this point right here. So when we talk about these x's and y's, one of those is coming from this point. So I have x and y, and yeah, let's call this point number 1, and k will be point number 2. So this means that x1, or 1, plus x2 divided by 2, comma, y1 is 4. 4 plus y2 divided by 2 needs to equal 2, comma 1. So what I did was I took this, and then I plugged in our point from J. I plugged it in here. Okay. Okay. Now I see. This has to be 2. The x portion has to be 2. And the y portion has to be 1. Because this is the x-coordinate of the midpoint, this is the y-coordinate of the midpoint, and this, I know these are the coordinates of the midpoint. So what this means is 1 plus x2 divided by 2 equals 2. All the x stuff has to be equal to the x-coordinate. And then, okay, I can solve this. This is an equation I know how to solve. I want to get x by itself. So I'm going to multiply by 2 on both sides. And then I have 1 plus x2 equals 4. Subtract 1 from both sides. And x2 equals 3. And wait a minute, look at that. We said that the x-coordinate of k was going to be something like 3. And it was. Beautiful, beautiful. How do you think we're going to find the y-coordinate? Think about that. I'm going to get us some space here. I'm going to erase some stuff and give us some space. If you weren't done writing that down, that's okay. Rewind the YouTube video, pause it, and then you can write it down. So the y-coordinate, all of this should be equal to the y-coordinate, because this is the y-coordinate of the midpoint, and this is also the y-coordinate of the midpoint. So these things are the same. So I can set them equal to each other. 4 plus y2 divided by 2 equals 1. Ahaha! I know how to solve this too. I'm going to multiply by 2 on both sides. 4 plus y2 equals 2. And then minus 4, minus 4. So y2 equals negative 2. Wow, I am good at guessing today. Okay, okay. So here we can erase that question mark now. We were right. x2 was 3 and y2 was negative 2. So k, the coordinates of point K are 3, negative 2. So this example, we did not know what the midpoint was. We were trying to find the midpoint. And in part B, they gave us the midpoint and we were trying to find the other endpoint. So you want to know how to do both types of those problems. Okay, let's check our answer. Midpoint, negative 5. Or excuse me, 5 halves, negative half. And yeah, coordinates of K are 3, negative 2. Beautiful. And they set it up just like we did. Perfect, perfect, perfect. Yay. Okay, now, that's all we're going to talk about the midpoint formula. Now, we are going to talk about the distance formula. Now, we'll talk more about this on the next slide. Personally, I don't think we should teach the distance formula right here. I think we should teach it later. So, right now, you are just going to have to trust me, and you're just going to have to memorize this formula. I really don't like telling you to just memorize things, but we have not learned about the Pythagorean theorem. The distance formula comes straight from the Pythagorean theorem, but you don't know about the Pythagorean theorem yet. So I can't completely explain to you where the distance formula comes from. So for now, you just have to trust me, and you have to either memorize this. If your teacher doesn't give it to you, then you have to memorize it. If your teacher does put it on the board while you take tests, or let you use it virtually, that's another thing. But this is the distance formula. If A, point number 1, has the coordinates x1, y1, and B is point number 2, so it is x2, y2. If these points are points in a coordinate plane, what a coordinate plane is this. A coordinate plane is just a graph like that. So that's what we mean when we say coordinate plane. If these points are points in a coordinate plane, then the distance is this. Yeah. You're just going to plug your numbers right in here. That's x, that's y, and then you'll get an answer. If you don't like that, just being told to memorize something, that's okay. I'm going to explain just a tiny bit the connection of where the distance formula comes from. So, the distance formula comes from, on a plane, in the graph, you see y-axis, x-axis. I have x2, y2, x1, y1. If I want to know the length of this, so, and we're finding this length is what we want in the end. But you can find this length by, in a right triangle, we know that a squared plus b squared equals c squared. You might have heard that before. But so you can figure out the long side if you have the two short sides. So what we're doing over here is we're figuring out the distance. We're using the ruler postulate to find the length of this vertical side of the triangle. And we're using the ruler postulate again to find the horizontal length of this triangle. And then a squared plus b squared equals c squared. So when you take the square root of all of this, you get the distance formula. That was a very poor explanation. I did a quick explanation on purpose because you don't need to know this explanation in order to do these problems. So, I'm going to show you two different ways to use the distance formula to solve a problem. So let's jump right into it. Find the distance between the 2 points, R and S. Well, first, let's put them on a graph. So R is at 2, 3. And S is at 4, -1. So these are our 2 points. Okay. Now, the distance formula, right up here, I know that the distance, or the length of RS, is equal to the square root of x2 minus x1, all of that squared. So you're going to subtract them, and then you're going to square them. And you're going to add that to y2 minus y1. Oh, squared. And let me fix that. We want this square root to go all over all of that. We're taking the square root of all of that. So, I'm just going to take these points and I'm going to plug them in here. But I want you to notice something. x2 minus x1. y2 minus y1. It doesn't matter which point is number 1 and which point is point number 2. It doesn't matter. What does matter is that you subtract 2 minus 1, 2 minus 1. If you change this and you do x2 minus x1 and y1 minus y2, you're going to mess everything up. So do not make that mistake, because I have made the mistake before. Make sure that you are doing 2 minus 1, 2 minus 1. Okay. All right. So, here is way number 1. I'm going to show you 2 ways. This is the first way, and then I'll show you the second way in a little bit. Okay. So, first way is I have x and I have y, I have x and I have y. Again, it doesn't matter which point is point number 1 and which point is point number 2. For simplicity's sake, I just do the first point that they list is point number 1. Second point they list is point number 2. You can pick whatever you want, doesn't matter. Okay, so x1 is 2. So wherever I see an x1, I'm going to put 2. y1 is 3, so wherever I see a y1, I'm going to put 3. x2 is 4. So wherever I see an x2, I'm going to put a 4. And y2 is negative 1. So wherever I see a y2, I'm going to put negative 1. And now I'm just going to fill in everything else from this formula. So remember that I squared both of these, just like up in this formula. And then I took the square root of all of it. Cool. Now, we have numbers. These are all numbers. So I'm just going to figure out what this is. 4 minus 2 is 2. So I have 2 squared plus negative 1 minus 3 is negative 4 squared, square root of it. And you can plug all this in your calculator if you want to. Once you get here, you can just put it in your calculator. I'm just breaking it down so that you can see the process. All right, so now 2 squared is 4. Negative 4 squared is positive 16. And again, I'm taking the square root of all of this. Forgot equal signs. And now 4 plus 16 is 20. And I keep the square root symbol. Now your calculator might show you, when you get the square root of 20, instead of square root 20, you might get 2 times the square root of 5. These are the same thing, but you don't know that yet, and you don't know how yet. We will talk more about that later on this year, and eventually I'll make a video by itself of how to do that, so maybe you'll see a tiny little eye in the top right-hand corner of the video, and if that is there, you can click on it to see what I'm talking about right here. But it's not necessary for what we're doing today. Square root of 20. That is the same thing as 2 times the square root of 5, or you can just put in your calculator square root of 20, and it will tell you that that's approximately, so I took the equal sign and I made it squiggly. This means approximately, and this means exactly equal to. The square root of 20 is approximately equal to 4.4721. I'll just round to 4.5. Now, this problem did not tell us to round to the nearest tenth. It didn't tell us to write our answer as a decimal. It just said find the distance. So you're going to have to know, what does your teacher want? Do they want the square root of 20? Or do they want you to give them the approximate 4.5? Me? I don't care. We're in chapter 1. I don't care if you give me just square root 20 or if you tell me it's approximately 4.5. I don't care which one you give me. Yeah, but check in with your teacher to see which one they prefer. Okay, so that is way number 1. That is method number 1 to do this. I wish I had left more space because I don't want to erase this. Okay, so way number 2, we don't have a ton of space, but we're going to make it work. So way number 2, or method number 2, you make a t-table. X and Y. Now, you're going to put the X of your, you're literally going to write this point, your first point, you're going to write it 2, 3. Just like it has it right here. R is 2, 3, so you write 2, 3, right here. Now write the next point, 4, -1. X, the X coordinate is 4, Y coordinate is -1. Just like that. Now that you have this table, what you're going to do is you're going to minus. You're going to go 2 minus 4, 3 minus -1. So 2 minus 4 is -2. And 3 minus -1 means I'm actually adding 1. So that's 4. Now you'll notice this, there's a 2 and there's a 4, just like we had in here. Only one's negative, one's positive. Doesn't matter, because when I square it, I get the same thing. So now you're going to square these two numbers and add them together. Negative 2 squared is 4, plus 4 squared is 16. So see, these are the same thing. And then when you add that together, you get 20, and you take the square root of it. And that's way number 2. Yes, so I'm sorry it was so cramped. I'm sorry we didn't leave room. But that is way number 2, and you get the exact same answer, whichever way you do it. So if you liked the first method, you're like, I just put numbers, that feels good. Or if you don't want to memorize formulas and you like this table method, do whichever one that you like the best. So that is example number 4. Let's check and make sure that we were right. Square root of 20, approximately 4.5. The squiggly symbol means is approximately equal to. So the distance between, oh yeah, forget about that. The distance is approximately 4.5. I took out the word problem because, I don't know, it was confusing for just an introduction to the distance formula. So look at that. Wonderful. We did it, and we got it right. That is what I have for you today. We learned about the midpoint formula. We learned about the distance formula. How do you feel about those two things? How do you feel? If you feel good and you're like, yeah, give me some problems to try, good, you're in the right place. We're gonna see those on the next slide. If you're like, I am still here, I am very confused, that's okay. Asking questions gets you the light bulb. And light bulbs, ideas, epiphanies means you're learning, and we want to get to the learning. So, in order to get to the learning, we gotta ask some questions. So, ask your questions, phone a friend, talk to your teacher. You could comment on this YouTube video, but talk to people when you have questions. All right, of course, your practice problems that you can do to practice all of the skills we learned here. Example 3, this is part A, or question A from example 3, and this is part B of the example 3. So here you're finding the midpoint, and here you're given the midpoint. And then example 4 is finding the distance between the 2 points. I know this is a lot of problems. That's like 16 problems? Oh, that's not too bad, but still, it's a decent number of problems. So, do the problems that your teacher assigns, not necessarily just these. But, a lot of practice for you if you want it. Alright, and as always, we will end our video with a launch. So today's launch comes from William James, and he says, excuse me, it is our attitude at the beginning of a difficult task which, more than anything else, will affect its successful outcome. We all like successful outcomes, right? We like to finish the things that we're trying to do, and we like to do them well. So, more than anything else, your attitude at the beginning of a difficult task affects its outcome. If you want a successful outcome, you want to do what you're trying to do, and you want to do it well, at the beginning of that difficult task, have a good attitude. Have an attitude that says, I'm ready for this to be hard. Like, accept, like, yeah, this is going to be hard. I am going to have to work at it. I accept that, and I'm ready for it. I am ready to work hard because I know that I can. I know I am capable of hard work. I know I am capable of perseverance. And if I work hard and I keep trying, I will get this. That attitude is what's going to help you be successful. If you go into it with the mindset of like, no, I don't really care if I get this or not. Like, I might try a little bit, but if it gets too hard, I'm going to give up. Like, no. If you go into it with the attitude of I can always just give up, then yeah, why wouldn't you take the road of giving up unless you really want it? And if you really want it, you're going to work hard for it. So enter your difficult tasks with an attitude of, I can do this, I am awesome, I'm going to work hard, and I'm going to persevere. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching.